Hi, my name is David Blankenhorn, Chief Cloud Technologist at DLT Solutions, and I'm thrilled today to be sitting here with Dr. Ron Ross from the National Institute of Standards and Technologies. Ron, welcome. Great to have you here.
Thank you very much. Thanks for having me today.
We're excited about having you at the GovDefenders event.
It's great to be here. Great to be here.
We're looking forward to the keynote. To kind of help prep the session today, got a couple of questions for you.
Sure.
So this year's GovDefenders panel is really focusing on the NIST framework for improving critical infrastructure cybersecurity. So kind of give me a gut check. How pleased are you with the current adoption rate? Where do we go from here? What are the next steps? So kind of where are we today?
Well, the framework was a great initiative based on the executive order that came out about a year ago. And it really has extended all the work that we've done in the FISMA work over the last 10 years for the federal government. The framework brought together all of the critical infrastructure sectors as customers. And they actually helped NIST build the framework. So everybody was a stakeholder. It was a real collaborative effort.
Mm-hmm.
Now that it's finished, we're going to start to see the adoption across the critical infrastructures. We don't have a lot of data yet because it's very new.
Right.
But the important part is that when you go through the framework and look at all those top-level functions, and you work your way down through the framework, at the bottom, we have all the best practices that have been around for a long time. For the electric sector, the NIST controls are there,
Right.
The ISO 27000. So it's a very broad-based framework, so every customer can use that framework. We can use it as an organizing construct to get our arms around the problem and use it as a level set, and then end up still employing the kinds of standards and guidelines that the sectors have been used to.
Gotcha. So definitely it's out there, it's new, people are starting to
They should
look
dive
at it
in and
dive into it.
Just understand what it's doing and try to adopt it to their own organizations. So that's the beauty of the framework. It's broad-based, it's a meta framework in some sense, and you can actually see your organization within that framework and use it to the extent that it talks to your missions and your business case.
Okay, so it's not meant to be prescriptive then.
Yeah.
Okay, gotcha. Okay, great. Next question I have is continuous monitoring. There's such a broad context around continuous monitoring. From your perspective, can you kind of help frame that for people who may not necessarily be as familiar with some of the nuances?
Sure. Well, continuous monitoring has been around for a long time, actually. We had it in our publications as early as 2006. To me, it's a very simple concept. With the way that the computers and the networks are built today, and the very dynamic world that we live in, the threat space is changing constantly, the hardware, the software, the firmware, the people, the buildings, the environments of operation, all of that change can potentially change the protective measures that you've implemented in your system when you first put those into place. So understanding and having the situational awareness is the term we use. What is the current state of my security today within my organization? If you put in a new operating system, or you brought in a new application, or you hired a new person, what is the impact on that change on the things you previously deployed? So we look at continuous monitoring as, are the controls that I put in my system in the environment of operation, how effective are they today based on the current threat space? And then we also use continuous monitoring to manage change. And so as those things happen within the organization, we can respond in an effective way. So it really promotes continuous improvement of the IT infrastructure, so to speak.
Because obviously IT is not, it doesn't remain in stasis. There's constantly evolving technologies, evolving threats. So
Yes.
making sure that we're constantly reviewing, keeping track of how and by the way, architectures tend to drift over time as well.
They do.
When
They
things
do.
get patched or upgraded.
It's kind of a good news, bad news situation. We have the greatest technology in the world. We use it to the max. We're very productive. But the fact that things their innovation is going on at such a rapid pace, that technology is changing. And so we have to understand where that change is going, and so we can manage that change, still use the technology to be productive, and yet be as protected as we need to be to make sure our critical missions and our business operations are not going south. Because that IT, like it or not, we are totally dependent upon that technology for mission and business success today.
So you mentioned in some of your other presentations I've seen in interviews, tacit, threats, assets, complexity, integration, and trustworthiness. What are some of the strategies around that to help agencies reduce security complications?
The tacit concept actually came to me over the Christmas holidays. I just returned from Korea and gave a speech over there, and I was thinking about if I had 5 or 10 minutes with a C-suite executive, what would I try to tell that person in a very short time to really focus on the important things that they need to be concerned about with the current dependency on IT and the threat space and all the things that we talk about every day. And so those 5 areas came to the top of the stack. Understanding the modern threat space is critical today because you have to personalize it. You can't just go out there and say the sky's falling and we're always under cyber attack.
Right.
You've got to look at specific threats and how they can impact specific vulnerabilities in your organization and what the impact to your business is going to be if that happens. And once it's personalized, then their heads are in the game, so to speak. That's the first aspect. The integration and the complexity, all those things are intended to try to get a better handle on the IT assets that you have, especially the critical asset identification, the asset part, is really important. We have so much IT today that we can't protect everything to the highest degree. So understanding what parts of your system, which systems, which information are the most critical, you can then separate those things and possibly add additional security measures to protect those assets to a higher degree because they are so critical. So that's what the tacit concept's all about, building trustworthy systems, greater assurance, adding greater strength of mechanism so we can try to stop more of the cyber attacks through having stronger IT to begin with. And that's why continuous monitoring doesn't work very well if you have a very weak IT infrastructure. You really have to invest first in strengthening that. I use the example of the broken lock on the front door. You can check it once a day or you can check it 1,000 times a day. The lock's still broken.
Still broken.
Yeah, so the challenge for agencies, and we'll talk about this later in the keynote, is the ability to make good investment decisions and say, I'm not going to spend all my money on continuous monitoring at the expense of strengthening my underlying infrastructure.
Right.
So all of that in the tacit approach is trying to focus on 5 areas that a senior executive can really understand. And to me, the most important part of the whole security business is that we have to be able to make good risk-based decisions and do as much as we can to protect our critical assets so the business can remain productive and can do what it's supposed to do.
Great. So it's a very balanced approach then.
Very balanced.
Obviously, you can't continually monitor this stuff if the whole thing is squishy in the first place. You get to monitor all the breaches that take place.
Exactly. That's,
okay.
Yeah, that's right.
Okay. Now you spoke before about the need for better security built into IT systems and architectures. What would you like to see specifically from the IT vendor community, and what is still missing when it comes to government cybersecurity needs?
Well, this whole area of security is a very complicated problem, and a lot of people look for silver bullets or one organization or one group or one technology to try to solve all of our problems. The real answer is these are difficult and challenging problems, and it's going to be a multifaceted.
There's like no easy button.
There's no easy button here, and it's going to take a partnership with the government and private sector. We have the greatest information technology vendors and developers in the world. You can see the amazing technology they produce. And one of the things that we'd like to see, and we have a publication that hopefully will be out at the end of April, to talk about systems and software engineering and how can you build stronger, more penetration-resistant component products like operating systems and database management systems, network devices, and then how are those component products assembled in a more secure manner so you can get greater penetration resistance, greater resiliency out the other end. So, the IT community is doing a lot right now to improve the level of security. We're trying to lead by talking about some of the best practices that companies could undertake. Many of them are already doing that, but those that are not, I'd like to encourage them to step up the game and try to do better so their customers have fewer vulnerabilities on their end once those products are delivered. Most of the time, when these products show up, it is what it is. There's not a lot of things you can do in a federal agency to determine if the access control mechanisms in an operating system are working well.
Right.
We don't have access to the source code.
Right.
But the developers can use those best practices. There's international standards. There are NIST guidance documents that can help improve the level of, reduce the number of latent errors in the software, and that will translate to fewer vulnerabilities down the road.
So I think a great starting point would be for vendors to actually go and look at all the NIST materials and see how they can internalize that and build that into their development processes or their testing processes.
And it's not just the NIST guidance. So we have a lot in there. There's a lot of things in the international standards arena, the IEEE, the IETF. There's just a wonderful body of knowledge out there that people can go to improve or even start their programs moving in a different direction.
Great. So, being a cloud technologist, I have to have at least one cloud question
Sure, always,
in the mix. All right, what is the impact well, rather, how is cloud impacting continuous monitoring strategies?
Well, cloud is a very interesting technology. It's a computing paradigm, and it's a form of, I think, enterprise architecture. It relies on the on-demand nature of the business, so you don't have to own everything, and that's really good for security, whether you're talking about continuous monitoring or just having a better security program. One of our big challenges today is we have a lot of IT, and we have a lot of complexity. And cloud in general allows us to reduce and manage that complexity because you don't have to own everything. Whether it's a public cloud or a private cloud, you can pick your choice and based on your risk tolerance.
Right.
Software as a service, platform, hardware, all of that there's a lot of choices out there. But at the end of the day, going to the cloud can have you build more efficient services for your customers, which is important. It can reduce your overall IT costs by 5 to 40% because you don't own everything. And the most important thing from a security standpoint is you have less IT to worry about, so you can do a better job at understanding what you have and how to deploy the right security controls at the right place in the architecture to really make a difference. So there's a threefold benefit for that. Continuous monitoring the cloud is no different than in regular systems.
Right.
We have a lot of virtualization going on. It may be being done in the public cloud by one of our great vendors out there, but nonetheless, the steps in the risk management framework, the sixth step is continuous monitoring. And the vendors can do that just like the government can, and they can provide that information back to their government customers or to their private sector customers. They can use the information again to get back to situational awareness. How good is the system today? What things have changed, and how should I respond to that?
Right.
So no matter what side of the street you're on, cloud or general purpose, vendor or government, it all works the same way.
Great. So a common problem we hear about within not just government agencies, but actually in the entire industry is really the lack of trained IT security professionals, the lack of these cybersecurity experts. How can government help address this shortage or this gap?
That's a very difficult problem today. We have a severe shortage of cybersecurity professionals, both public sector and private sector. When I talk to young folks today, I say this is a great career opportunity. So the government, we have our national initiative for cyber education at NIST, and we've defined lots of different roles and responsibilities in the cybersecurity business, from development all the way to operations and sustainment, all across the life cycle. And I encourage people to look at this as a career. One of the things I'm afraid is happening today is we're dumbing down the definition of what cybersecurity professionals should be. It's not just configuring your firewall or your network devices. As you're going to see with some of these very significant vulnerabilities that we are experiencing now, that have been in the news, a lot of this goes back to the good software development techniques. And so having a generation, the next generation of people coming out of colleges and universities that understand software engineering, computer science, mathematics, systems engineering.
Right.
These are the things, these are the disciplines. I use the bridge building example in my talk, that bridge builders talk about physics, and there's properties that you apply to make sure that bridge can withstand the loads. And we have to apply the same fundamentals of our science and technology and mathematics to the software and hardware development processes, the system development processes, to make sure that the software that we're giving to our customers in those systems can withstand some of these cyber attacks, especially the things that we absolutely should be shutting down because of best practices. So I think it's a great career. The government can be a cheerleader. We can do things like define the roles, responsibilities, encourage people. I try to do that all the time in my public speeches, is to encourage young people to look at this. It's a great career. And it's difficult. I mean, taking computer science courses is sometimes not a lot of fun, but I enjoyed it. But some people don't enjoy
Not for everybody.
it. Not for everybody. But if you want a very productive and exciting career, one that transcends, there's a little bit of patriotism there. There's a little bit of technical challenges. It really has a lot of politics, technology. Everything is rolled up into this thing we call cybersecurity. It's a great field.
So the annual OMB FISMA report shows that almost 90% of the enterprise cybersecurity spending goes towards personnel. Do you see automation as being able to maybe bend that cost curve a little bit over time and relieve some of that pressure on the requirement for like these more highly skilled, highly trained staff?
Automation is great. The new DHS program that John Stroiford has been working on, continuous diagnostics and mitigation. There's a lot of automation being built into that in the continuous monitoring genre, so to speak. And in my view, automation is good because it does things more efficiently. For example, when you can update your virus, antivirus signatures through automated techniques, or you can do an inventory of all of your components with scans. Automation is really good because it does things that people don't do very well.
Right.
That's number one. So that can save you a lot of personnel costs right there. But the bigger issue, the more things we can automate, then we can free up the people to solve the difficult and challenging problems. You see, right now, a lot of our good people are running around chasing vulnerabilities and doing all these things that we could automate and we could do a better job in that aspect. And all of that, those are wasted clock cycles, because then we can't put our brain power on solving some of the really difficult and challenging problems that deal with some of these high-end cyber attacks, which talk about better software, better systems engineering, all those things. That's where our brain power needs to go. So the more we can do with automation, the more people we're going to have available to solve the difficult and challenging problems.
So you alluded to an earlier question around some recent developments in the security industry. So what are some of the guidance and tools that NIST has actually put out that might have mitigated some of the issues that we've seen around things like the new Heartbleed bug?
Well, these are complicated problems. And it's always easy. Monday morning quarterback is always really good, easy to do. 20/20 hindsight is always perfect, or hindsight is always 20/20. But in the Heartbleed situation, there are best practices out there. Now, this was one of those unusual vulnerabilities that popped up. When you look at the actual source, and we've looked at the NIST controls to see what could have been done. There are some obvious ones that when we have a control in our SI family, the integrity family, called SI10, which is an input validation check. Just checking parameters and boundary conditions, things that you would do routinely in a software development process. But that may not always catch some of the very subtle programming things that happen. We also have some controls in the SA family that deal with developer testing. So once that code has been developed, you can go back and either through manual code reviews, or we have a testing control that looks at, we call it the threat and vulnerability testing analysis. So things like penetration testing, figuring out from an adversary's perspective, a bad guy, what could you do to this small amount of code that would predict some of the bad things that might happen? If the payload, for example, is less than what it's purported to be, what could happen on the other end when the memory is overreached or overrun? So these are things that are not always obvious, and no one likes to point fingers or play the blame game, because this is, again, everybody's trying to do what they can to improve, and sometimes things there's oversights that happen. But I think these are all teachable moments where you can come back and say, what could we have done, looking at what happened now? And again, you can't verify and validate every piece of software, all the applications and all the millions of lines of code. But what you can do, and this goes back to tacit, the second thing in tacit, assets, criticality of the software or the functions that are providing that capability. What we can do is look at software that's going to be very critical. We call them, these are security critical functions, security enforcing functions, things that are part of very sensitive aspects of the system, whether it's the crypto area, whatever it might be. Those assets, we can do a little better job at scrutinizing, possibly, to make sure that something like this doesn't happen again. And again, it's not easy to do, but you can't do it everywhere. But we got to be able to understand, what's important, and especially for those things that are going into hundreds and thousands of servers, being involved in very sensitive transactions worldwide over the internet. It's a tough problem, but we can maybe use this as a moment to reflect on how could we have done this a little better in the future.
Great. Dr. Ron Ross, thank you very much for your time.
Thanks.
Great talking to you.
Nice talking to you too.